So a quick introduction to who I am. I work for Autodesk within the technical specialist team. So my role is to help you adopt the software, make the most of the technology you have access to, as well as then if you do have any additional challenges, then how do we overcome them with the use of the Autodesk portfolio. So I sit within design and manufacturing. I'm covering UK, Ireland and Nordics, but I'm part of a much bigger team. So if I can't get you the answer, I probably will know somebody that can. So yeah, great to meet you. And I have a product specialization in data and process management. So expanding on from what Adam was presenting with Vault, we're going to look at today process management, so PLM, product lifecycle management. And we try and go outside of engineering a little bit, which is why when GRAITEC asked me to do this session, they came up with the idea of beyond data management, because normally that's where we have a lot of conversations, we're comfortable in data management, but what happens before and after design? So to start with then, what is product lifecycle management? Well, the idea of it is to get rid of all of this mess that a business might have. So as you probably know, within your companies, different areas and departments will have their own system, right? Design and engineering might have Vault, it might be using SharePoint. Quality might be using something like another Excel spreadsheet, a QMS system. Procurement will probably have access to an ERP system of some sort, holding financial data about the product or the parts that you buy in. But there's still a lot of over-the-wall data being thrown around. We might export a bit of content here, like a bill of material, pass it to another department. Our goal is to actually remove this and remove the inefficiencies. And a lot of the time, engineers' desks look a little bit like this, right? Because there's always somebody that's coming up and saying, can I have a copy of this drawing at this revision and this release? What we want to do is move you onto something that is a bit more slick, a bit more efficient in the background, and hopefully drive towards an automated process management system so that you can do your job and say, that's done, it's released, the next person then has access to that information. And that's exactly what PLM is. In terms of the product, we separate it into, it was 6 core areas, it's now 7 core areas. So everything from product design, maybe even managing a portfolio of our products, quality management, supply chain management as well, the idea of being able to deliver goods, services, data downstream to our supply chain, and maybe even getting information back from them as well. But we've also just released things like product ideation. So the idea of actually coming up with an idea within the business and then following that through the product development process. Who's heard of, I'm looking at the 3 of you, have you heard of PLM or Fusion 360 Manage before?
360 Manage.
You've probably Fusion 360, but yeah, okay. Yeah?
Not 360 Manage.
Not 360 Manage?
No.
Okay, right. Yeah, so not to be confused with Fusion 360 CAD authoring. This is our management process management tool. And we also have something called a template library. And the idea of that is that companies are doing some wonderful things with this technology, and we see that. So what we do is we build out a template process and we give it back to our existing customers. And we're going to show you some examples of what that looks like. Now, following on from what Adam was showing with Vault, this is normally where we have the conversations. An engineer will be coming up with their designs, nuts, bolts, washers, relationships between these huge complex assemblies, and then managing that data in Vault. At that point, they will be changing the revisions, managing then, who has access to which bit of that design, before then releasing it to the business. And this is where PLM normally comes in. If you could imagine, if you are a product company, you're doing continuous improvement down here, but there'll be a point in time where you need to say, right, okay, we're happy with this, we're going to release it to the business. Again, if you're a project-centric company, you might say, right, okay, the first iteration of the design for this customer's requirements needs to be purchased. At that point, then we will send it up to PLM and then possibly down into an ERP system like SAP. So to give you an idea, CAD designs are managed within PDM, but we're looking at the before and after, and this is where the process management side comes in. So, the before might be requirements management, and might be the idea of collecting ideas from the business. It might be product, also project management, NPI as we refer to it. But new product introduction within a company might be classed as something slightly different. Sales to engineering. I mean, what do you call it within your business? What would be your product development term? Product, yeah, okay.
Yeah, as is MPI.
MPI, yeah. A project, your project centric? Okay. So again, the idea of managing that. And then the after tends to be more change. You know, how do we react to change? How do we collect what might be a problem report and actually refer it down to the engineers who are making a form, fit, or function change? All right, so let's look at the before. And we're going to look at some examples of what this actually looks like. Now, typically, these are the type of systems we're dealing with within a company. A customer relationship management system might be holding all your customer information, opportunities, leads, things like that. But there's a lot of processes that span across them. So new product introduction isn't just an engineering function, it's everybody within an organization. Change management should be everyone in an organization, but it tends to fall to engineers. So we're going to start with sales, and we're going to look at when somebody maybe comes up with a quotation, it's maybe a request for some information, how we can transfer that into an engineering project. So what we've got here is, this is our internal CRM system. We use Salesforce. What we're doing here is there's a salesperson that has took an inquiry. It might be over the phone, it might be via email, and they're filling out some information and they're uploading maybe a PDF that the customer's actually sent over to them. So we've got that information there. We filled out the property card. Now what we're going to do is we're going to start to move that through the workflow. So again, this is just an integration mock-up that we've came up with. So once we're happy with that, we're going to close the opportunity as, I think, won in this case. So we've won the business, then we now need to execute on that. So once we've saved this item card, what we're going to do in the background is send this information up to PLM. So now we're in Fusion 360 Manage, and we've started to initiate a project. And as part of that project, we've actually collected the PDF that was sent to us by the customer. And that might contain requirements of what they actually want. Now we also have another example where it's an online configurator. Somebody said we want this, 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 and this, and we've pushed it through into a project. Just gives you an idea of how a project can be born. Now once we have the project, we generate it from a template. That might be because we have a very complex project to execute on, or it might be a bit more shorter lead time. So the idea of being able to generate your stage gates, your milestones, and what tasks people need to do from a template tends to save time. And again, everything will roll up into a Gantt view. So we can see here that when we're at the concept stage, how long should it take, who needs to do what, and where are we up to today? So as a project manager, I can go into here and I can say, all right, we're currently at stage gate number 3, and my engineers actually haven't created our conceptual designs yet. We haven't done a failure mode effect analysis. We haven't done any simulation, and that's holding up a project. So being able to view what's going on and why. Everything we do within here, all this information that we're filling in will be rolled up in the reports and dashboards as well. So if you are a project manager, or if you are managing a project, then you can see, right, okay, well, are we on track budget-wise? How many orders do we have going out the door for this customer? Are engineering needing to do something? Or have we already done what we need to do, and it's actually the assembly team or maybe even the procurement team that are laying it up? Now, what we've tried to do is visualize the entire end-to-end workflow, and we're going to take some steps here as we go through. So this is the initial sales part. Now, we've just implemented something called the ideation module. So what we thought is we had a lot of customers that said what we want to be able to do is document a requirement and then come up with the sub-requirements after that. And then if the changes at any point, revision control those sub-requirements to make sure that we are keeping track of what changes were made. So if it is a customer project, if they came back and said to you, oh, you know what, we don't want it in yellow, we want it in black, we can actually go back and see when they made that change or that decision that affected the requirement, and then hopefully build them for it. Or if it's someone like we did a simulation and that's altered the requirement, we can see why. But it all starts with an idea. And the idea of tracking ideas in a system tends to be something that a company mightn't initially consider, but once they start using this, it's good to be able to open up a database to everybody and give them the opportunity to say, right, okay, for this product improvement, wouldn't it be great if it was, I don't know what all the products are, but if it was on casters, if it did this feature and function. Now, what we can do is we've generated a templated system, something that you can start working with out of the box. Somebody can log an idea, they submit that idea, add support and documentation, and then other people can go in and vote on it. And if it is a good idea for the business, then what we can do is we can take that into what could be an MPI project. Requirements management then is a little bit more detailed. So as I mentioned before, it might start off a top level requirement. Who's seen this slide before? Has anyone seen this? It's great, this. So in terms of, this is how the customer wanted it, this is how the analyst designed it, this is what the programmer wrote, the sales guy described it as this, how it was documented, I love that one on the end there. This is what the customer was billed for a lot of the time. And this is what the actual customer really needed at the end, right? So the idea of documenting these requirements up front is key. Now, what we can do here is take either a customer's requirement and document that, or we can then generate it directly from an idea. So as you can see, we're working through this workflow. What we've done is we've built this using a bill of material workspace. So a top level requirement can have sub requirements, just like a bill of material might have sub features, which allows us to then bump the revision of a certain sub requirement and being able to go back and trace against that. Again, what decision affected this? Where are we up to today? Have we got any approvals that need to go through the business? This just gives you an idea of some of the workflows that you are buying into out of the box with PLM. And ideation and requirements management are fairly new to us. In terms of then defining a project, as you can see here, we've got linked directly to the requirement, we've now got the MPI project. So we've went through, we've documented these, now we've got a staged gate system. So a graphical workflow where we can say, right, I need to move from gate review number 1 to gate review number 2 and get this approved. Now in the background, what we'll be doing is we'll be allocating tasks to individuals. So you might get a task to say, go and run a simulation on this component because it's a part of the detailed design part of this project. So you will be allocated a task, either via email or in My Outstanding work pane, and you can go in and complete that task, upload your documents directly from Inventor, from Vault, and link them to this project. Once you've done that, you'll complete it on the workflow, and then everything's rolled up into the master project in that Gantt view. Now, this seems to be one of the most common use cases we go after, change management and new product introduction, because a lot of companies will be managing this in Excel or in something very similar. At this point then, we've generated the project, we've assigned an engineer maybe a task to go away and create that design. They've done that, they've released the design up. So then the business, the project manager, can start to maybe share that deliverable with the customer. So they can go in and do things like design reviews, and they can start to manage a bill of material. And this is what the bill of material looks like. So what we've done is from the project, we've clicked through into the bill of material. You can see this came from Vault. So we actually have a tab that takes us back into Vault. But as part of that, we're actually sending up a preview. In this case, it is just a DWF. But because I'm on a Autodesk web page, I'm able to go in and use the viewer. I'm able to go in and inspect, explode the design, maybe add a markup at this point. So if you are sharing this information with somebody that doesn't have access to the design tools, then this is a good way of doing it. We can also attach the support and documentation that might come with it. So PDFs, as Adam mentioned before, STEP, DXF, that type of thing. Now, as we drill down into the bill of material, what you've designed is a CAD bill of material, parts list. At this point, the bill of material might need some additional information. It might need, they've ordered 10 spare parts of this one component. We might need to put in here some packaging, a pallet, a skid, anything like that. And we can do that in this bill of material. It's completely disconnected. Disconnected is not the right word, but it's separate from what we have is the CAD BOM. This is the engineering BOM, where we can change the quantities, but we can also go back over and say, why did that change, right? Is it a customer that's emailed in to say that they've changed the quantity from 10 to 8 or whatever else. Now we've got the bill of material and we've got the design data, we can start to do things like design reviews. So you could manage the process of your design review directly with your customer or whoever else needs access to it. So what you can see here is we've got our product and we've got our product preview. In this case, it must be a company buying a massive jet engine. So you can see here, within that viewer, again, we can do things like explosions, inspections. But what we're doing here is we're managing the process of the design review. So what were the requirements? Is there any support and documentation that goes along with this design? What does the bill of materials structure look like? And we can start to inspect each item and click it through into the 3D design. Now, once we've been through this and we've collected all our findings as part of the review, we can then start to generate actions off the back of it. So maybe our customer doesn't agree with the location of this door, this opening, anything like that. And we can put a markup on the drawing and create an action off the back of that. So this task here is to check something that mightn't be quite right. And it is all related back to that markup. So I think the key challenge that a lot of customers have is actually giving feedback back to design of what needs to be changed from a form, fit, or function point of view. This gets around that. But once we've got an engineering bill of material, we can start to translate that into a manufacturing bill of material. So what you can see here would be as we select a component from the EBOM, it will be highlighted in the 3D view. And then we can start to generate a manufacturing bill of material. And in the manufacturing bill of material, there's this option down here to add in steps. So you can see here's our pre-assembly. We might say stop and do a check, refer to this documentation, talk this up to a certain setting, start to add in those steps into a bill of material structure as well. So if you are in the assembly team, you can see the component, but you can also see the step. What's quite nice in this extension that is being built is we have a disassemble option. So we can use the 3D view and we can click the components and disassemble it in the 3D view and build up the manufacturing BOM that way as well. So quite a nice extension. We then have to release this to the business. So we've got our engineering bill of material. We now need procurement to go away and buy it. And this is the next stage. So we use engineering change orders to do that. So we've changed the quantities. We're happy with it from an engineering point of view. What I'm now going to do is automatically push this into what could be an ERP system. Now, normally, when I'm dealing with customers, what they're doing is they're manually doing this. They're taking that engineering bill of material from an Excel spreadsheet or an inventor parts list and punching it into ERP. What we're doing is we're automating that task completely. So you're happy with it, you've got the structure, you click a release button, and it will automatically appear in an ERP system. And that's because we have an open API that we can integrate into most ERP systems. Not all. They have to obviously have an API that we can access, but most do. Then, from a supplier or a spare parts point of view, how do we then enable other people to have access to this information? So in this example, this was actually a customer we worked with, and they manufacture these huge machines, and they said, our spare parts business is actually costing us money at the moment because it's such a heavy process. Wouldn't it be great if we could give the customers access to a 3D model and they can click on a component, find that component in their design and find if it is a spare part? And if it is a spare part, can we order that directly from the 3D design? So this is our version of their system, but we actually have a really good case study where they've recorded a video and showed exactly what theirs looks like. The company's called Andritz. They make huge bits of industrial machinery. But you can see here, we found the component we need. Now we're saying that, right, this is actually flagged as a spare part because on the bill of material, it's just a tick box to say we do offer this as a spare part. As you can see here, spare part, yes. And we've submitted a request. Now in PLM, we're managing that process. So we're in a workspace at the top there. Don't think that pointer works. It's in spare parts requests. This is the workflow to say that it's been requested and the parts list is being driven. Again, it's an item, right? It's an item. The exact number came from your design and inventor, being released into the system, and now we're then saying it's a spare part and it's been requested by the customer. Then on to quality. Now quality is it's a very own topic completely, but the idea of being able to manage a quality process against a design is exactly what we try and achieve. So you can see here we've got an 8D process. So the 8D process, I believe, is part of the Six Sigma workflow. So the preventative actions type of thing. We also have non-conformances as well. So if you are inspecting raw material or goods in from a supplier, we can manage things like inspection protocols. If it's wrong, we then log it as a non-conformance against that supplier, which again might be a bit of information we pull from ERP. And then that non-conformance might link into a corrective and preventative action, which we have here. So we're starting to manage the process of CAPAs. If it is a problem that's not our supplier's problem, it's our problem, then we can start to translate that into a change request. Change request will then eventually land on an engineer's desk to say, go change this. And then the process starts again. We reissue that BOM. And that leads us in right to the end of the workflow is collecting problems. So a problem report, in my opinion, should be accessible from anyone in the business. Assembly, maintenance, not just engineering, anybody, even the customers to a degree. We can even open this up to them. So what we're doing now is we're logging a problem report. We're saying, what's the affected item? And you might have a QR code that gives you this information, or you can search for it. What's the quantity, or do we want to attach things like an image or a PDF that goes along with it? Once we've submitted that problem report and given our feedback and generated all that feedback, what happens next could be, right, we allocate somebody a task and they're going into my outstanding work pane to say that we've got a problem and we're going to start to inspect what that problem is. So you can see there we've done a technical analysis, but we actually haven't filled in a bit of information that we need to do. So we're going to go away, edit the form, and actually assign somebody a bit of work to do. They're going to do that technical analysis on it. So here's the target date, the completion date, there's the technician that's been selected. Now, as you can see here, we're moving this through the workflow, and at this point here, it actually becomes not just a problem report, but a change request. So the problem is not just, something that is maybe a user error or something like that. It's actually, this hole is in the wrong place. This now is the start of actually reporting that down to the engineer to go away and change the revision of the CAD design, the form, fit, or function of the design. That then goes back through the process all the way to this point where we reissue the bill of material, and then we go back through this stage. Or in some cases, if you want to be more agile, we might jump some of those as well.